Hello, everyone. Welcome to another episode of React Roundup. I am your host today, Paige Niedringhouse, and we are joined by TJ Van Tol.
Hey, everybody.
And Steven Wittens is our special guest today.
Hello.
Welcome, Steven. We're glad to have you on. Maybe you could introduce yourself to our listeners and give us a little bit about your background and why you're famous.
I don't know if I'm famous. I usually introduce myself as the guy with that website with that crazy header, because it's kind of my calling card. So the website in this case is acco.net, acko.net. It has a very elaborate animated 3D piece in the header. And if you're wondering why it's called acco.net, it's because if you put www in front, it just says wacko. That's a 20-year-old joke, but it still works.
It does. And anybody who's listening, I would definitely encourage you to check out his website because it is very cool. There's music included. There's some awesome animations. But I think, Steven, what we're actually going to talk about today first, at least, is a piece that you recently wrote called React, the Missing Parts.
Yeah, definitely.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So what I've essentially been doing lately is playing with my own version of React. And where this came from was the realization that after doing a lot of front-end code with React, then moving back to back-end, I often found that there'd be moments where I'd be like, oh, it'd be really handy if I could use a hook here. Or it'd be really handy if I could just, take this list of things that I'm making where only a couple of items are changing, just like in your UI, and I could just use React to do that. So out of this idea, I built my own React-like runtime. It's called Live, but it's essentially mostly a clone. But what it focuses on is the core part of React, just the notion of you have components that produce other components, you have hooks. So the very essence of React, but without the HTML part, really. It's just the internal part because I want to use it for things that aren't UI. And so I've applied this to WebGPU, to build a framework for GPU rendering on the web, and basically found that it's really great. It's all the benefits that you get when you work with React code. You can get in other domains that aren't necessarily UI, or they might still be rendering or drawing related. But you quickly discover that anything around that, any sort of orchestration or bookkeeping around that, if you write it in a reactive way, it becomes simpler, and you get all the same benefits that you're used to from UI land. And so as part of that, once you have your own copy of a framework, you can kind of just play around with it and experiment with it. And because it's more lightweight than the full React package that does HTML and has years and years of effort put into it, it's a lot easier to evolve it. And out of that came a couple of experiments. These are some interesting concepts that I think would be great if they were present in the main React library, but also that I can make use of now because I have my own tool set, and I'm just applying these patterns as much as I can because they make my life as a developer a lot nicer.
So this is very cool. I think the first question I'll ask just to start, it's very cool, but it's also quite ambitious, right? I think most developers that notice this sort of thing don't think, oh, well, to look into this more, I'm going to build my own version of React, right? So I'm curious, how did you go about starting something like that? Did you have up the React source code? Do you have some background in that? Or did you just kind of try to take it from a naive, let me just reverse engineer these APIs and sort of as a learning exercise? I'm just sort of curious your approach when you took that on.
No, it's definitely a fair question. I should say I have a lot of experience. So I'm 38, but I've been pretty much been coding ever since I could reach a keyboard. So from a very young age, not that, those first 10 years amounted to much, but still it means I have a lot of backgrounds in just UI concepts, rendering concepts, and those kinds of things. When I started with React, that would have been, I don't know, very early on. That was back when it was still mix-ins. I don't want to put a year on it because I'll get it wrong. But yeah, back when React still had mix-ins, that was before classes, way before hooks. So I watched that whole evolution kind of happen, mostly from the outside. But before that too, I've worked with UI frameworks, worked with rendering engines, looked into, various sort of UI paradigms. Like there's two fundamental concepts in this space. It's what's called immediate rendering or retained rendering. And kind of until React showed up, those were kind of the two only ways. And I would say what's great about React is it combines those two methods. It feels very immediate when you use it, but nevertheless, we all know it's retaining a whole bunch of stuff behind the scenes for you. So yeah, having that background helped. In terms of how you actually build it, it's a little bit of what you say, just going at it from scratch, not worrying too much about how the official implementation does it. But at the same time, having worked with React a lot, having, stepped into it using the debugger on numerous occasions, even just, even when I don't want to, you kind of get a feel for what's inside there and the kinds of concepts that they're using, which is very useful. But I definitely approached it as I'm going to do a clean room implementation, exactly because it's not tied to all the same HTML legacy concerns. So I can get away with a lot more than they can. Basically, it doesn't have to be quite as
robust.
Robust, definitely. Not quite just as complex. It's not juggling as many balls, and that just alone allows you to keep it a lot simpler.
Yeah, it's sort of, so back in the day, I've not done the same sort of deep dive with React, but back in the day, I got really involved with the jQuery project. And I did a lot of similar type experiments where the jQuery source code can be incredibly intimidating, but you also have to realize that they're handling all sorts of edge cases for you that you probably don't need in your code, right? It's like some edge case that they have to handle crazy, like different iframe usage, different, like all sorts of different browsers, lots of which you probably don't care especially about. And by taking like the naive, dumbed down approach, it can not only be a good learning experience, but it can also make some of this framework stuff seem less magical, I guess is one way of phrasing it too. Because it's not like it's insanely complicated into the hood. There's just people maintaining all of this stuff.
Yeah, exactly. And so, I mean, a good example of that is what happens when you don't have class components. When you only have functions and hooks, that's a whole chunk of complexity that just goes away.
Goodbye.
Yeah.
Exactly. The React team can't do that. I can do that. So it's more these kinds of trade-offs that I've been making. There's an interesting conversation to be had, for example, about React 18 and where they're going, where they do seem to be becoming a bit more opinionated in terms of how they want it to work. Whereas I think before, until React 17, they were a little bit more just like, well, we don't want to steer you too much. We're going to let you do whatever you want, whatever you're comfortable with. I don't know if that's a good evolution. So from that point of view, it's also nice if people are exploring alternatives to copy a lot of the same benefits without necessarily having to adopt the whole stack wholesale.
Yeah, I mean, I appreciate the fact that the React core team has tried to make React as backwards compatible as they can as they've moved forward. But, you can, if you keep up with what's going on in the world, you can see that there is definitely a trend toward hooks and I think that you have to assume as a developer that at some point they are going to stop supporting class-based stuff and you really need to move everything over or just say this is the cutoff point. React 17 is where we're staying. We're going to eventually hit that breaking point where we can't use classes. So, I appreciate that. And I appreciate that they didn't do what Angular 2 did, which made it just completely incompatible with Angular 1 or Angular JS in any way, shape, or form. But I also understand to keep the code base not so bloated and not so complex. Eventually, you just, like you said, you have to start going in a certain direction and cut out some cruft and just say, this is the direction we're taking. If you want it, go for it. If you are happy with what you've got, then just stop letting the versions increase.
Yeah, it's interesting too that the React team has spent the last, I think, two major releases kind of working on exactly that, on potentially having different versions of React running side by side, so that this may be exactly what you're thinking, that they're just going to, they're going to drop the class-based components, but still allow you to run old React in the way that it was back then. And then they can, layer on newer concepts without having to carry it back.
I'm presuming too, as you were sort of building this up, that I'm guessing you were just building features of React as you needed it, right? Because you have no desire to be like API compatible, right? So if you didn't need a certain, like some of the more fringe hooks or like some of the features that people rarely use of React, I'm guessing you didn't go back through and feel a need to implement those, more or less, just the stuff you need to get what you need done.
Yes, although I would say, there's sort of the core set of hooks that are kind of essential, which is, the state, the memos, and the context.
Yeah.
Those you can't get away from. But it's true. It's definitely not a full, 100% implementation. There's a couple of the more esoteric hooks missing. Then again, I think a lot of those, if you look at them in React, a lot of them are also just sort of convenience wrappers, that they don't necessarily depend on any special internal magic to do what they do. So that's definitely something nice that you realize once you start sort of tinkering with this at their lower level, is just how little you need to get something like React going. Like the concept of, a functional component that could access hooks, that access, a piece of state that is somewhere, but you don't really know where, you don't really care where. It's really not that complex once you build a little proof of concept from it. And then the rest is just, how do I want to evolve it? Do I want to follow the same sort of design guidelines, the same principles? Do I want to break some of the rules? That in particular was the fun part, I think, that a lot of what are rules in React just don't apply anymore. So for example, like a big frustration I'm sure many people will have found is that you can't call hooks conditionally in React. We all know why you're not supposed to do it. It's very nicely documented, but still sometimes you just want to do it. And you can't, because that would, cause the hooks to shift around and change. But there's a workaround, which is this. Imagine you have an if statement, and inside that if statement, you call a hook, whether it's, use memo, use context, whatever it is. And then in the else branch, you just call use no context, use no state, use no memo, so that you're explicitly telling your runtime, like, hey, I skipped a hook, and it was this one. And once you do that, you can call hooks conditionally as much as you like. And it turns out it's really useful for certain things. Like if you want to make a component that depends optionally on a context, like you want it to be able to be used either with a context or directly, depending on how you want to use it. In traditional React, you would have to make two different versions of that component. With conditional hooks, you don't have to. And in terms of, the code and reasoning about it and what it's doing, it's very simple. It doesn't really add a lot of complexity. It doesn't fundamentally break the rules. It just says like, hey, if you want to do this, you can. So that's one of the things that I was able to get out of the model, which is really, really nice.
It's interesting stuff. And I get the sense too that this is the process that a lot of some of these, because there's like a new wave of frameworks that are trying to be the next React, right? Like your Sveltes, your Solids, and and a lot of these are clearly, like thinking Svelte in particular, like clearly React inspired, right? Like you can tell it was a similar thought exercise was done as you just went through, right? Like, let me take the bits of React I like, but hey, some of this stuff I don't really like, so let's just ditch this. Svelte has like an opinionated way of doing CSS, whereas React doesn't. Like, you can tell that somebody's just like, I want to recreate React in my own way. And that's how some of these came about. So I don't know where I'm going with this. I guess I'm curious, do you have any plans to try to like spread the word on live to popularize it? Or do you see this more as just your own internal just experiment, just a fun place to play with it?
Yeah, definitely. I mean, I'm using it to develop a graphics framework. So for me, it's a means to an end. I just knew I wanted a copy of React without actual React. So that I needed that to do my graphics work. So that is open source. It's already online in an alpha version. So right now it's mostly a demo app with some cool little toys that you can play around with in a web GPU enabled browser. But it is a proof of concept of something big, which I'm hoping to keep growing. And turn into sort of a generic toolkit to do graphics well on the web, especially in terms of customization and extensibility. Because there's a lot of great 3D solutions out there, but they're all quite black boxy. Like if it does what you need it to do, then it's great. But if you need to step outside those bounds, you're kind of stuck, or you have to fork it, so on. So that's what I'm trying to use it for. The nature of that work is it's also a little bit ambitious. It involves GPU programming, shaders, a lot of math. So that in turn also makes it a little bit more niche. But I am doing it all out in the open. You can go look at my code in the horrible state that it sometimes is in, with all the warts in the master branch, because that's how I roll when I'm just coding for fun and nobody else needs to care. But hopefully it will stabilize. I have already released parts of it as NPM packages. I don't want to push stuff out that's unfinished or unreliable or quicksand. That's just not going to help anybody. But stay tuned for sure. It will keep growing and keep getting pushed out there. To your point about the frameworks, by the way, I find it kind of interesting that React pushes in a certain direction, and a lot of what these other frameworks are doing is kind of pulling back a bit, back towards more traditional HTML, CSS. Whereas for me, the decision I made was the complete opposite. It was React is great at HTML, so I don't need to care about it. I'm just use React for HTML. Because why would I build a copy of something that already works perfectly and that other people are maintaining? It's much better if I can, use this model to do novel things in a space where it isn't used, and then just have really good React interoperability, and Bob's your uncle. So
yeah, I find it so cool that you're taking React and just extending it into a space that really hasn't, I think, gotten a lot of, well, I can't speak too deeply about it, but it seems like WebGL kind of got to a certain spot and then just kind of stopped. So as long as you're good with math and really happy to deep dive into that kind of stuff, you can manage it. But if you want to have a nicer API or library or something on top of it to make it easier, it doesn't seem like there really has been that option before. So maybe you could give our listeners and us more of a primer on why you would use WebGL and WebGPU and things like that.
Yeah, for sure. So WebGL and WebGPU is just using the native hardware capabilities that your computer or your mobile phone these days have to render 2D and 3D graphics. It seems super obvious. It seems like it should be super commonplace that we're all trying to do this because it's right there. It's very capable hardware. And for some reason, we don't. Why is that? And I personally, I kind of blame the video game industry in the sense that computer graphics hardware has heavily been, driven by that market. And if you look into, the video game industry, it's not a great place to work. Working conditions are quite bad. They have this problem that there's, a sort of a line of interns by the door just waiting to be hired and just be, crunched to death 60, 80 hours a week. And once they're tired and once they wise up that, maybe this isn't how you want to spend your 20s, there's just new interns that you can go hire. There's a couple of industries that work like this. And the video gaming industry is kind of like this. And so as a result, there's not a lot of sort of efforts to really improve the base technology. It's very project driven. Just work to finish the game, do whatever you need to do to get it out the door, and then we move on. There are, of course, things like Unreal Engine and Unity and so on, which are great at what they do. But again, they tend to be sort of, monolithic integrated packages that are mainly designed for a particular kind of graphics, I would say, like, photorealistic or like photorealism, but very little that's like diagrammatic. That's really data viz oriented, mapping, any stuff like that, scientific visualization. It's not great at it. It wasn't the primary use case, so there's just this void of really good software to do this. And that's what I'm trying to focus on and trying to make better. So I don't know if that answers the question.
It's really interesting because it's like one of my pet peeves too is that for whatever reason, native mobile developers tend to reach for these sort of things. Like, I think if we put the games aside, because obviously games have like high graphic needs, but I feel like there's a lot of apps, and you mentioned some like just like data visualization, mapping, those sorts of things that could benefit from some really like slick animations and visualizations and graphics and such. And I find that native apps tend to reach into the native hardware far more often than just your average web app. Like it seems like there's a lot less polish for some of these like higher end, like, even companies that have huge development teams and budgets. They tend not to push the boundaries on the web when it comes to graphics very often. And it's kind of disappointing because a lot of the tech, at least as best I understand, a lot of the tech in the browser is actually there now. It's just severely under leveraged, it feels like.
It's a little bit of column A and column B. The web has the problem that it has to run everywhere. So when it comes to 3D graphics, it's kind of the cheapest, crappiest phone that determines what we're allowed to play with. Compared to, a desktop computer with a $1,000 NVIDIA GPU, there's toys in there we can't use on the web. That's just how it is. But you're right that there's a ton of power there. And I think that the answer there is we spend a lot of our energy just getting it to work, wrangling the DOM, dealing with CSS and transforms and so on. So that's also an area where I'm just trying to see, like, how much can I get away with just skipping that? If I'm just rendering to a canvas, how much can I do? Can I get a basic box model going? Can I render decent text? And yeah, you can do a lot. And it's a lot of work if everyone would have to do this stuff from scratch. But at the same time, if we had more components for this, I think people would be experimenting a lot more with it. It's sort of, the browser Chrome is set in stone. We can't do anything outside that boundary. But if you had components for that outside part too, it would be a lot simpler. So
yeah, no, it's true. I've been a web developer for a very long time. I've known about WebGL for a very long time. But if you ask me today, like, oh, you need to implement this on your website, I wouldn't know where in the heck to start, right? Like, I don't know what I could look things up, I'm sure, and try to piece some things together. But I think the fact that there is no very well known, like, here's what you do to solve this problem, or here's what you go to use this, is kind of telling, because it's not new tech on the web. This has been stuff that's been available, at least in some capacity, for quite a while.
Yeah, it's just because everyone builds a solution for rendering particular things. That's kind of how it's been done in the field. And so you have all these silos that do certain things well, but if you want to do anything else, you're kind of on your own. And it's like, well, let's build a team of graphics developers for our little web app. Like, yeah, no, that's not going to fly.
So you mentioned as you were building your own version of React that there were some rules that you rewrote. What else besides conditional hooks did you decide to go in a different direction than the original team?
Oh, well, one thing that I think is really interesting is the notion of morphing. And the best way to introduce this, I would say, is ask the question, why does React Router keep changing its API? No, it's a good question. They're at version 6 already. It's not like routing is, so mysteriously complicated that why did it take them 6 tries? I think that's a good question. And I'm not trying to throw shade on them. I think there's a real problem there, which is when you're routing, you kind of want to make, different pages, different page components, right? To organize your app. But one of the rules of React is if you replace a component of type A with a component of type B, you have to get rid of it. It has to be remounted. You cannot preserve any state from A to B. And of course, when you're actually, making a web app or a website, most of your pages are going to have lots of parts in common, right? And so React basically just throws those away and then mounts them again. It might keep some of the HTML, but it won't keep the state associated with it, right?
Right.
And so my idea was, well, do we have to? What if I could specifically say, for this kind of scenario where I know I have these, components that are all shaped very similarly. They're really just, interchangeable. I kind of want to treat them as if they were one family of components. This I added to the runtime. It's called morph. So that you kind of just wrap a thing in a morph tag, and that signals saying, hey, if you encounter, if there's already an existing morphable component here, just put this one in place and keep all the children.
Mm-hmm.
And that's basically what it does. It's still going to remount the components of the page in question, but it's going to keep all the children around and just say, like, hey, can I not use any of these? Are any of them still good? That's basically all it does. And I think this is one of those concepts that I think would totally work in React. I don't think there's anything special about it. You just kind of have to realize, like, no, this isn't, a violation of data flow rules. It's not a violation of good taste. It's actually really useful. Yeah.
Yeah, I feel like it's kind of like the conditional hooks. It's one of those like it's like a hazing ritual for new React people, right? When you figure out that this doesn't work, because you kind of intuitively want that state to be preserved when something gets swapped out, because it sure would make your life a whole lot easier if when the header gets re-rendered, if it still knows what account is information to put up there or whatever the case may be, right? And then when it's not there, and then you have to go like, oh, okay, well, I have to, figure out how to architect this to support this. It's always like a bit of a wake up call that's right. This is how React works. Let me go back and figure out how I need to do this.
Yeah. And so to that, my point about React Router is, I think the reason they keep redesigning is because they keep coming up with ways to circumvent this problem, but they can't fix the problem. Mm-hmm. So in the latest API, they have something called outlets as a way to do this. And outlets is really just a children prop in disguise. It's literally the same thing. It's a slot where all the stuff gets put into. It's just a different way of doing the same thing so that you don't have to make a new component out of it. So I think that's why. And I think morphing would be a lot better, but it definitely has to be opt-in. You don't just want to change all the rules of React and say, we're going to keep all the state. We're going to, state for everyone, just like Oprah, because that's also going to change too much. It's going to lose some of those separation guarantees that you actually do also want. And so figuring out when you want behavior A and when you want behavior B is part of the fun.
So I'm here with JD from Raygun. JD, when I talk to you, I mean, I really feel the developer vibe, and I know that's your background. But is all of Raygun that way? I mean, it just kind of feels like when I talk to other companies, they're a little more corporate, a little more focused on maybe, raising money or doing other things, But it seems like when I talk to you, you're just, down to earth developer dude.
I like to think of myself as a down to earth developer dude. Raygun is a little bit different. So, we're not heavily VC backed. My business partner and I, when we started, we were both nerds. I might be the CEO today and I don't write code on the product. But, the joke internally is, what's the definition of technical debt, Chuck? It's CEO code. Well, stuff to go fix. But no, we're
stories.
We're a cash flow positive business. We're not heavily VC funded. But we are at a size now where we are expanding, and more folks are discovering what we're about. But yeah, we often look through things through that lens of a developer. I wanted a 30,000 foot view, but I also want to go right down to an individual data point. Similarly, I don't believe in averages. I want medians. I want P99s. I make better decisions that way. And so we try and drive that sort of thinking into our products and try and be as developer minded as we possibly can be.
Yeah, I love that because, for me, it's run by people who get me. And you're not under pressure from like a VC to raise your prices or, go hyper grow. And then, oh, crap, now we're behind the 8 ball with our money and now we've got to figure it out. You're just going to keep growing, steadily moving. And I just love that.
Yeah, I mean, the term these days is often referred to as product-led growth, right? Like get people use the product and say, hey, that's great. I want to give you money. I don't think it's that complicated.
Sounds good. Well, folks, if you want to go check it out, you can go find them at raygun.com. You can actually sign up for a free trial right there on the website.
I have to imagine memory could also get out of control too if you were tracking all the things in a really complex app. Or am I thinking about that wrong?
No, it's not going to track anymore. It's literally just saying, because React already keeps the whole tree of your components in memory. That's why you can inspect it in the dev tools. And so the only thing that's changing is just saying like, hey, even though this component changed type, just don't throw away the children just yet. Just wait and see if any of them are still good.
Oh, interesting. Okay.
Yep.
Have you thought about either suggesting these or like opening some pull requests on the React core team for some of these things that you're doing? Because like you said, a lot of them are still in the spirit of React. And especially if they put it behind an opt-in flag, maybe other people would find it just as useful as you are.
Oh, quite possibly. The thing is, I only have so many hours in a day, so that's my excuse for not opening a React pull request. I would also say, Facebook certainly has the means to copy what I did. So if they want to, they are more than welcome to. I'm not going to say no, but that's unfortunately where I have to leave it today. Like I don't have a lot of time to become a core React contributor, fortunately.
Yeah, that's one of the benefits of having your own fork, right? You also don't have the not that your code wouldn't be polished, but like the getting stuff like that across the finish line for a project that operates at the scale of React is, I have to imagine, is an absolutely enormous investment in terms of time, resources, etc.
Yeah.
For like, I mean, some notoriety, I guess, if that's what you're going for, but it's just like, I mean, no one's going to pay you to do that, right? So it's a whole lot of time to sink in.
Yeah, I would also say, just the fact that it's patterned after React is, I think, a decision that I'm really happy with. Because I could have just I could have said in certain places, well, I'm making my own version of React, so why didn't I go crazy? Why did I do what Svelte and Next and all the other guys do? I just say, like, let's change as much as we can. And I explicitly didn't do that just so that I could say, like, hey, do you know React? Then take a look at this.
Yeah, then you'll automatically...
You know exactly what's going on. It has exactly, it reads exactly the same, has the same JSX. There's a couple of additions that change the rules a little bit, but it's not, world changing. It feels like it could just be, React 20 that's just here early in that regard. Yeah.
So what were some of the WebGL and WebGPU things that you want this version of React to be able to do? Because that's very interesting to me, is like, what could you potentially do with this new version?
It's really just making it simpler. No, but it's difficult to explain this. This is because I've been trying to explain to a lot of people what this project is about, what Live is, what the graphics framework, which is called use.gpu. And it's called use.gpu because it's all hooks. So the word use is just everywhere. I'm trying to explain this because it's not that there's anything particularly novel that you cannot do today. It's making it dramatically simpler. Exactly the same way that, React didn't necessarily allow you to build things that you could not build before. It was perfectly possible in theory to build UIs of exactly the same complexity. You just didn't. And why didn't you? Well, because it was spaghetti. It was a nightmare. You took ages just to get it working, and then you didn't want to mess with it because it's
right.
But now with React, when it's declarative, you kind of do want to tinker with it. It invites playing around with it, and so that's really what I'm trying to bring to it. It's kind of hard to explain because it's like, people who are in the graphics scene say, well, I can already do all this. What's the what's the added value? And it's like, well, yes, because you spent years building up all your expertise and all your libraries and all your things. So now you're comfy. But somebody from the outside, they're going to like, well, I don't know anything about graphics. Why should I prefer your thing? And it's like, it's just simpler. That's it.
Yeah, I feel like you're talking to your target audience here because like Paige and I both have, JavaScript React background, but virtually zero WebGL stuff. And it is super intimidating. So anything that makes it easier. And by the way, use.gpu is a fantastic name. You should totally keep that.
That's what it does. It lets you use the GPU.
So do you wish it's just to go like a little one step further into your like let's just paint a picture of the future where all your work is done, it's worked amazingly. Is use.gpu, are you passing that things like components, like building blocks? Like I want to render a box here, right? Like, is it going to seem more like Canvas, or are you building up like a tree of components that gets rendered to WebGL instead of HTML through Canvas?
Yes.
I'm just sort of curious what you see the rendering sort of pipeline looking like in a WebGL world.
Yeah, this is the magic trick. That's, again, it's one of those things that's hard to explain. What you do in React is you use your component tree to produce an HTML tree, right?
Yep.
And then that HTML tree is your description of what needs to go onto the screen. What I find myself often doing is realizing I don't need a second tree of objects. What I really need is a tree of code. And it's sort of like I'm assembling a program at runtime, just a bunch of little snippets of code, one associated with each component, basically, right? Like instead of rendering a div, I just render a little function and say, hey, go call this when it's time to do this. And so your component tree kind of just turns into a program that gets just run top to bottom. And that's what ends up happening. So even though it feels exactly like, kind of like you described, you've got components to represent various sorts of things that you plug together into a tree, it doesn't really get turned into another representation. It kind of just sort of dissolves into code that runs and does the right thing. And that's, I think, what's really neat about this approach is, React was created in order to tame the DOM, but it's even better when there's no DOM in the way, when you can just go all the way to the end. That's basically the magic here. And I think that's still easy to explain to web developers, because I think web developers are just going to be automatically enthused about anything that makes the DOM even more irrelevant. It's just nice. But for graphics developers, this is all just like, I'm talking moon language. What are you talking about?
Yeah,
it's just so far out of how they tend to approach it.
Mm-hmm.
I think they would look at my code and just be horrified at how inefficient it is. And it's just like, well, I'm not rendering Doom. I'm rendering diagrams. Like,
you don't need 60 FPS.
Oh no, I need 60 FPS. It's just it's not hard to get 60 FPS because I'm not rendering Doom. Like,
yeah, I bet you get a lot of comments like, why do you need to do this? And to which the answer is you need like a lot of time to explain. Just browsers work differently.
Yeah.
So do you have some examples of seeing this? You said at the beginning that there were some live examples of this engine. What kind of demos do you have for people who want to kind of their toes into it and play around with it a little bit?
The demo is it's a React app that launches live. And I'm just using, like I said, React for HTML because it's good at it. But it builds a canvas, and then there's various little demos, just some 3D geometry, a basic sort of math plot of a 3D diagram. I've got some box model stuff. So, a page with some boxes with some text in it that you can scroll, and some Flexbox like things going on. Basic, that's the thing. None of it is particularly impressive. All of it you can do with other tools. It's just like, hey, look at how simple this is now.
Yeah.
That's really it. So it's both, if you understand what it's doing, it can be impressive, but otherwise I think it might be underwhelming until I can actually, put some time into making some really neat showcases.
Are you using it on your own website right now?
Well, no. So WebGPU, to be fair, I should probably clarify this. It's not really available yet for everyone. So you can turn it on in a dev version of Chrome, but you can't really use it in public. So this is another reason why publicizing this is so hard, because I have to record everything on video just to show it. Because otherwise, people just get a box that doesn't do anything, and they're like, I'm not going to download your thing just to look at it. Like, that's not how things work anymore. So I have to make videos.
I remember that being a common complaint of the Houdini API, which is finally starting to get to actual usability in Chrome and Firefox and things like that. It's like people would go to the example sites on MDN and things, and it wouldn't work because they were on the wrong browser or the wrong version. It's just like, it's kind of not fun when it's like you've got to go to the latest nightly release to actually see this thing in action.
Yeah, the best thing is just record videos. It saves you a lot of hassle.
So one question that I don't think I realized until you just mentioned this. So WebGPU versus WebGL, because I know WebGPU, the extent that I understand it is WebGPU is like the newer version, right? Like the more advanced version. But is it like a completely new set of APIs? Can you like write WebGPU code that like also can run in a WebGL environment? Like how exactly do those work together or not work together?
Yes, they don't work together at all, really.
Okay.
And the reason is WebGL is basically ancient. What happened was it's like I said before, it's mobile phones that are really driving what we're allowed to play with in a browser. So WebGL was modeled after the kinds of graphics you could get on like first, second gen iPhones, essentially. So 2007, 2008 is kind of it's computer years are worse than dog years. So that's ancient history. And there's been, of course, some updates, and there has been a WebGL 2 that was made, which definitely, had a couple of improvements, but was still fundamentally the same thing. And it's still that same API from, good 15 years ago. And OpenGL really is much older than that. So this is really 25 years or longer. So WebGPU is modeled after the more recent generation of graphics APIs, be it your Metal, Vulkan. So Metal is Apple. Vulkan is kind of the replacement for OpenGL. So it's the open solution, kind of like OpenGL was before. And then Microsoft has their Direct 3D. So there's a lot of fragmentation too, which isn't great, but that's what we're forced to deal with. But that does mean that WebGPU is kind of positioned perfectly as, and this is a horrible thing to say, the Java of GPU graphics. No.
Yeah.
Horrible analogy. The Unicode of, no, that's even worse. Oh, Jesus. It's meant to be, it harmonizes a lot of differences between those different platforms and gives you a common baseline that is relatively sane and well supported. So what's really interesting is whereas WebGL was kind of just a desperate attempt to get GL to work on the web, WebGPU is more just like, no, actually, a lot of people could agree and benefit from this standard even outside of a browser. So there's, for example, a Rust implementation of it called WGPU, which allows you to use WebGPU natively without any browser. And it's the exact same API, so you can potentially write code that could run in both environments really easily as well.
So is the browser then doing some of the heavy lifting in terms of just, because presumably there's code somewhere that has to talk Vulkan language, talk Metal language, talk Direct 3D, and just make that work behind like one coherent API. So I'm assuming like the Chrome engineers, Firefox engineers, etc., are some of the ones doing the lifting and the translation so that the browser gets like one semi-sane API to work with.
Yep, exactly. And this is a very slow process.
I was just thinking like I was not. It just sounds not fun.
It takes a certain kind of person.
Yeah,
that's for sure. I'm much happier being on the consuming side of it. I did do some early work with WGPU to contribute to some of very minor things. So it's not totally foreign to me, but yeah, it's not super great. And in part, this is also, there's the theory of what those APIs can do. And then there's the practice of, okay, what's actually out there in the wild in terms of devices? How bad is it? Is it just as bad as we thought it was, or is it worse? Spoiler, it's worse. But.
I was just going to say, it's probably not better.
Is there some sort of future proofing built into like this time around? Like, because like I'm just picturing, Apple decides we've come up with an entirely new way of handling graphics and such. Presumably, then it would be on the browser vendors to like talk to these new APIs to make sure that WebGPU continues to operate as expected on like any sort of newer APIs or hardware that comes out.
Yes, definitely. It kind of depends on where the market is going, where the devices go. There's definitely an evolution towards more generic processors. So it used to be that I don't know. Back in the day, way back, with 3D effects and those really early vendors, what that hardware did was